Hello, hello. Today we are going to shift gears and we're going to start looking at square roots. Specifically, we're going to look at evaluating square roots and simplifying square roots. So we have already seen what happens when we square a number. 5 squared means 5 times 5, which is 25. Also, if we take -5 and square it, that's -5 times -5, which is also 25. And so the reverse of squaring a number is taking its square root. So we can say the following. 5 is a square root of 25 because 5 squared equals 25. And also -5 is a square root of 25 because -5 squared also equals 25. In general, if b squared equals a, then b is a square root of a. All right. Now we have a symbol that we can use to denote square roots. You've probably seen it before at some point. This is a radical symbol, and it denotes the principal square root, which means the one that's not negative. So if we had the square root of 25, that would be 5. If we had the square root of 100, what number can we square to get 100? Well, either 10 or -10, but we're going to have 10 here because this square root symbol or radical symbol means we want the positive square root, the one that's not negative, technically. The reason I say not negative instead of positive is because if we look at the square root of 0, what number can you square to get 0? Well, the answer is 0, and that's not positive. It's not positive or negative. So it's bad to say the principal square root is the positive one because it could also just be 0. So we really say it's the non-negative one. If we want to talk about the negative square root of a number, we can put a negative in front of the radical, and this means we want the negative square root. So here, the negative square root of 25 is -5. The negative square root of 49 is what? -7, because we know 7 squared gives us 49. What about the negative square root of 169? Can you think of a number that we can multiply by itself and end up with 169? If you can't, you could guess and check. I think most people at some point learned the perfect squares, at least up to 100. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. We also have 11 squared, gives us 121. 12 squared is 144. 13 squared is 169. 14 squared, 196. Those are almost opposites of each other. We just switched the 9 and the 6. And 15 squared is 225. So here, the negative square root of 169 is -13. Now, these numbers here, we call them perfect squares because they are the squares of integers. Anytime we have a number that we can get by squaring an integer, we call it a perfect square. Now, some numbers are not perfect squares. If we wanted to look at the square root of 51, probably can't think of a number that we can square to get 51, but we can figure out something about it. Now, 49 is a perfect square. 49 is 7 times 7. And then 8 times 8 is 64. So because 51 is between 49 and 64, then its square root is going to be between 7 and 8. And so it's going to end up being 7 point something. Now we could use a calculator to get an idea of what this is going to be. If you type the square root of 51 into a calculator, you should get something like 7.1414284. And then it actually keeps going on and on forever. In fact, we have a special name for this type of number, a decimal that goes on forever and ever and ever, and it never stops and it never repeats. It is called an irrational number. Whenever we have the square root of something that's not a perfect square, we're going to end up with an answer that's irrational, a decimal that goes on and on and on and on forever. So the square root of 51 is an irrational number. The square root of 2 is an irrational number. If you type that into a calculator, you'll get something like 1.414213563 ... But it's not just square roots that are irrational numbers. There's another famous one. You've probably seen it. Pi is approximately equal to 3.14, but really it's 3.14159265358979, etc., etc., etc. It goes on and on forever. So in a situation like this, I would recommend using a calculator to get a good approximation and writing out several of the digits so that you have at least an approximation, even if it's not an exact answer. We will look at things we can do to simplify radicals in the next video.